Hi. Hello, Miss Setner. Anybody else watching this? Welcome to my evaluation. This is everyone that's here. So, all my evaluators and family members and friends who came. And this is my presentation. So my name is Maya Razum. I really love space. So I got my mentorship with Matt. The thing. When I got my mentorship with Matt, it was kind of great. He works at NASA. He's an electrical engineer, and I was excited to work with him because I wanted to know more about what it was like at NASA and be able to you know have an idea of what it might be like in the future. So this is me and him at NASA with the spacesuits, and basically. My first few days there at the mentorship, it was really, we met at Chick-fil-A a lot because of NASA's high security. I wasn't allowed there 24/7 or rarely at all. I've been once on site, and that was a great time when we took this photo. So that was after the government started back up. So, that was fun. So my responsibilities as at the mentorship, because I wasn't doing much at NASA, I was largely in charge of managing my project and time and completing any assignments he gives me, which is really like reading articles and moving on with my project to a place more advanced where I was, which at first wasn't very much. I was kind of struggling with homework, but I figured it out and I began to get really good at it, at what I was doing. Just took some time. So what I liked about it, the one time I went, was the employees were very friendly. They were just great and they were smiling and they gave me a little patch that I love. I have it in my purse. And I'm really proud that I managed to get my responsibilities together because I was struggling a lot and there were a lot of days where I showed up to mentorship and I was like, I got nothing done this week because I just didn't know what to do or how to do it. But as time went by, Matt was helping me out and I began figuring some things out. So it got great. Um, so, my goal is to go to Mars. Being an astronaut, I plan to study astrophysics and quantum physics and aerospace engineering to well, those are just things I really like, and also it's good for being at NASA or any other space agency because those are the kinds of skills they'd probably be looking for. So I'm very excited about that. So this is my project, the extraterrestrial base. I started out, I knew I wanted to do something involving space. So we spent some time. Matt brought his wife over one time, Joanna, and they helped me basically flesh out the basic idea of my project and what I wanted to do. His son also came over a couple times, so they were really helpful at first, and then I began figuring things out and doing things on my own, like I said, and I was able to do things while I was at home or at school, and so I was being more by myself. So that was actually really cool. We came up with these requirements near the beginning of what the base would need to be. We need to host 4 to 6 astronauts. In fact, the project that you're gonna see in a minute hosts 4. We need to be comfortable in like the sense of like it would be welcome for like having different people and it wouldn't be a stressful environment. It'd be as it'd make people as happy as possible in the restricted area of movement they have because I did end up designing it's on another planet. They can't go outside. They're stuck inside 24/7. So I tried to make it as welcoming as possible to keep them happy. It also needed to be completely self-sufficient. It'd have to produce its own power. It'd have to produce its own food because even on the moon, you're 3 days away from any kind of help, minimum. So it needs to be completely self-sufficient, able to live on their own. So it needs to have to grow food, and it's a base on the moon or the Mars or the moon or Mars. So it's going to have a research lab because that's one of the main reasons NASA has for going to Mars, for creating these bases, would be to do research on the moon or on Mars, learning things like what it's made of and seismic activity and those kinds of things. So it has to have a research lab. So we did, these are the final ones that were like the absolute must-haves. It has to be mobile and editable, which would basically mean we can pick up the individual modules and move them around if we need to, so that we can remove ones that are having problems, or we can add new ones, like if the base should grow at some point. We can do repairs without harming other modules. And they should each module should be completely capable of supporting supporting life, because if something goes wrong and is disconnected from the main power source, anybody in there needs to be able to survive until they can bring back the power, they can reconnect it, or get the person out, rescue them. So that's what it needs to do. So my research took over the course of about a month and a half. Matt was sending me articles every week, like 3 or 4 articles, and I would read those, and I get as much information as I could out of them. It was difficult. I couldn't figure out why I wasn't learning anything, why I wasn't being able to do anything. But it got easier when Matt sent me a video with an article with a video embedded in it, and I read that and I watched that video. And that actually explained a lot of things in the video, and I could see what was happening and why they were doing that. In the video, it was for a contest that NASA had done, where they were designing a Martian base. And so they were explaining the hows and the whys in the video, and I could see it as it was happening. It was animated, but you know, it was really helpful. So I began looking at more videos like that, and I was able to get a lot more information out of those, and that's where I began with my base. So I took notes. Each video was different, and then I began drawing and designing in 3 dimensions. I started with a piece of paper. I drew that, showed it to Matt. He gave me some comments, criticisms, and so I drew another one that was more along the lines of what NASA would do. And then I went on to my computer and I designed it in 3D, and then it ended up being terrible, so I didn't use that. These are some photos from the videos that I was watching. They're available online. Here is the YouTube link for this one. Search this Avis core. So I was able to see, and they're all completely different. So I was able to draw elements from one or the other, and figure out what I want to do. Like this one has windows facing upward. That's a little. You think that might be a little weird with the solar radiation, but they're reflective, they're protective windows, and so they're not going to harm. They're going to prevent, well, not prevent, they're going to help reduce that kind of solar radiation. These are designs, they have these escape ramps, so that if something goes wrong, you can get out. And not this one, but another one was circular in shape, so that you could always reach a different, module. Even if one went out, you could just go the wrong way. So that's why. So I took those into account. And then a friend of mine, actually Nicole, who is right here, suggested that I look up what they did with Antarctic bases, research bases, because Antarctica is kind of similar in that it's remote, it's cold, it's not habitable really. The main difference is there's an atmosphere. That's about it. So I took what I could from those kinds of things, and that's how I developed my, utilizing space and the colors and stuff, which you'll see in my video of my Minecraft design. I went into Minecraft and I did my design in Minecraft, and it took me probably a full day to do the entire thing, and then I had to record a tour of it so that I could show it to you guys. So here it is. start off, you can see up there just a minute ago, there was a little thing that is actually a, what's it called? That's an orbiter that orbits the moon. It has emergency supplies and stuff. It doesn't rain on the moon. It does not rain on the moon, but this is Minecraft and I don't have control of the weather. But right here you can see this is a crater rim, which would be beneficial on Mars to block winds and stuff. Which it's not very useful on the moon, but it's good on Mars, so I included that. This is the garage, and our main entrance right here is that door. And inside the garage we have 2 rovers, cars for people to go in and do, collect rocks, collect samples of things that they need. So they're kind of big and bulky because they're made of blocks and they're kind of small on the inside. They have this dark glass to protect against the solar radiation and the brightness of the sun because the sun's just so bright. This is the research area, research lab. In here, we've got, these are computers over here. And the flowers are there. Those are grown in the greenhouse, and they're just there to brighten up the room. These are each different things that could be used for studying materials. We've got some storage in here. We've got more windows because we want the place to be as open as it can be without, just to make things easier to tolerate. We're coming in here. This is the power room. It's easily accessible in case something goes wrong. Out there are solar panels. Those are providing the power for the base. Through here is the bedrooms, which are designed. We have this little flower because purple is a good color. It's good for creativity. We have these bedrooms. The orange is a welcoming color. It helps with happiness, but blue is calming and good. Blue is calming, so I included that in the color of the beds because we want people to be calm and able to sleep at night. We have this small little area over here. Oh yeah, these look slightly different because they're in the middle. I just wanted to show that. We have this area over here. Red is a color that can cause energy. So I included pink, and I have some red flowers in here. So I used pink for that. Through here you can see the lander in which they came through. It's the flattest area in this area, so that's where they landed. This is the kitchen. We have seeds. We have actual food. So those are like the ovens where you cook and stuff. And here you can see just into other rooms and stuff, so you can see what everyone's doing. And those are furnaces to cook everything. And through here we have the greenhouse. We have the flowers I pointed out. Right now I'm going to go into survival mode. Before I was in creative, right now I'm going to go into survival mode so that I can show you what I'm growing here. Because as you can see, I can't pick it up. But we have wheat, we have potatoes, we have carrots. Basically anything I get in Minecraft I put in here. In real life we'd include as many foods as we possibly could get there and realistically grow. There'd probably be cabbage, all those kinds of things. So we have potatoes, we have carrots, we have wheat. We have beetroot over there as well as melons. And inside, beetroot here, there we go. Those are pumpkins too. We don't need pumpkins on the moon. I just included those. Ignore the bats. This is where we grow mushrooms because they're mushrooms and mushroom stew is delicious. So we're back in the garage, which at this point I'm just going to run over to another door and show you that middle room that I haven't showed you yet. You might have seen me skipping a few doors. It's going to be right through here. This is the communications room and the exercise area. Because if you're on the moon or you're on Mars, you have lower gravity, and that's going to cause things like muscle deterioration and bone density and a loss in bone density. So this is a communications area where you can communicate with NASA or your family, or get together to talk or go over notes or anything if you feel like you can't do that in the research area because that was kind of, not really that great looking. The blue carpet is where we do exercise. Those are treadmills, the black things. plus some yoga mats, that's what the carpet is, and the dumbbells because it's Minecraft, I don't have very much. So that's my Minecraft tour of my base. And that's basically the end of, that's the whole thing. It would be slightly different in real life because Minecraft, but you know, so that's awesome. So my conclusion, I want to thank everybody who came for coming and being here for me and just being awesome people. I want to thank Matt's family for helping me out, and I want to thank Miss Hampton, who owns this classroom, for letting me use her classroom. And I want to give a very special thanks to Matt and Miss Setner, who is the ISM teacher who organized the whole mentorship thing, the mentorship program at this. So I want to thank them. So thank you. Do we have questions?
So I have a quick question.
Yes.
So for your final design, you had mentioned one other group watching your videos that gave me, there's a circular one. Is this one also circular? So
It is circular, which it was difficult to see, but I did go around and come right back to the garage. So I hope that it was evidence through that.
It seemed like it, but I wanted to make sure.
Yeah.
So.
All right. Any others?
When they have the, say you have the, like the eating area, and then is the lab attached to, or the, where you're growing, the grow chambers, the different things that you have, is that part of the lab, or that's like a separate?
That's separate, because that's just for food, and there also is probably going to be research going on there for like microgravity or low gravity compared to Earth, but that's mostly for food growth, which they need just because you need food, right? So they're producing water they're collecting it from the ground, from ice, or from reusing their own water, and then they're growing their own food. Yes.
So, from listening to your presentation, we discovered that your goal is to actually go to Mars
Yes.
and to be an astronaut. And so you have provided us with a model of what your base would look like on Mars or the moon. So why do you think it's important that you and other astronauts do this research to learn how to sustain life outside of the Earth?
Well, one main reason is that currently, and I'm gonna get a little, this is a little kind of political, but like we're kind of destroying the Earth, and we've with just pollution and gas emissions and all that kind of stuff. So we want to find a way to like have a way to preserve human life. But that's kind of a worst case scenario. It's more along the lines of we need to do research. We need to know what the universe was, the solar system was like in the early solar system, which is going to be beneficial by looking at what's on the moon, what's on Mars, what's in asteroids, what's on other moons, and so this is a bridge to get there. And another reason would be space would be profitable. There's going to be industries that are going to go out and mine asteroids for rare earth materials that aren't as rare on asteroids. They're just rare on Earth because they were heavy and they sunk to the core and we can't access them. And asteroids didn't do that. They don't have those dense cores. They're kind of small. They're tiny. Like the entire asteroid belt is about 10% the mass of the moon. So just having all of that stuff, knowing all of that, and having access to those resources and having access to that knowledge is very important to science and humanity in general. So,
Thank you.
Anyone else? No? All right. Well, thank you. Oh, is this Kim? All right. Thank you for coming.
Trainers, your overachievers, your astronauts, divers, you name it, physicists, marine biologists. Because you never know when you're looking at whether it's human spaceflight or exploring other planets, what makes us, why are we unique or not? What put it all together? What made it, what makes life sustainable? One of the other things I participated in is a program called United Space School. And every summer we host students from the U.S. and there's a whole bunch of families that do it. There's about 40 to 50 students, and they're juniors and seniors in high school. And their goal is to divide up into teams and to build a base on another planet, usually pick Mars. So this is a very easy way for me to use as a template to help her with the mentorship project and learn more about what does it take to go to space, what does it take to do a space mission, what types of things do we do while we're there. And she expressed that she had to do a project as part of this mentorship to help explain what she was learning along the way. And we looked at all kinds of different ways to, how would you do that? Do you build a diorama? Do you build, and she certainly has a creative streak there, very imaginative, and very, I'm trying to find the right adjective, but very involved and focused on a lot of different subjects. And some of this, you've got to focus yourself down to how do I handle this versus that. And it's overload of information. And part of the process was figuring out how to assimilate all this information and say, okay, this is important, this is a little less important, this is more important, and trying to put it all together. And I think she did a really good job of using all the different tools that you have to put it all together and display the information. One of the things we do very similarly in the United Space School project is they have to use recyclable materials to build a base, a model of their base. Can't use a computer. They can use a computer to kind of help illustrate, but actually have to build a physical model of it. And what do they have? Not very much other than their suitcases and their clothes and that sort of stuff. Well, at lunchtime, they start collecting pizza boxes and water bottles and any other materials that are there at the school while they're doing this over a 2-week period. And they glue it all together, paint it, whatever. And when they came to visit my office there at the center, I had a pizza box model of the Mars base on the back of my wall that some students did previously. My wife also worked at the center. She's a physicist. And I've had different jobs along the way. My current one is working with the spacesuit organization. So managing the suits that we have, which some of them, it's an evolution of a design that we've been using since the first guys, right? In space. But I've been blessed to have a lot of different things to see and actually working on a design reference mission for Mars. It's various iterations that we keep dusting off and coming up with new ideas. So, I would encourage all the students in the room here to explore. There's lots of information out there, lots of things to get interested in, and lots of opportunities. Part of it is trying to provide opportunities for you to learn more about what we do as adults, right? We do our own thing. So, we made do with what we could, and I ride my bike to work every day. So it was very convenient to go across the street and meet at Chick-fil-A because it's on the way home. And we met at the library. We looked at a lot of different things when trying to figure out how to best present the information. So we went to the 3D printing lab there at the library, everything, the CNC machine, and looked at all the different ways that she could work on that. I would do the mentoring program. And, it's one of those things you don't know what you have to offer. You actually do it. It's like, so, who wants to hear from a lecture? I've kind of done a few other things along the way. And I hope that you've learned something as part of that. I didn't mean to get you frustrated.
Oh, no, I was frustrated with myself. Thank you for all of that.
Is it something that you think that you can extend on because because it is something that you want to do to like refine your design?
Probably, like, given more time, I probably could have gone with the 3D
Oh,
printing route.
no,
which,
just something that you might want to just do, not as part of a project because you just like it. I
I
was
mean,
fascinated by it.
I do this stuff. I mean, I like to do this stuff for stories I write and those kinds of things. But with stories and stuff, it's less how reputable is my source, how accurate is this going to be, is it feasible? It's more, will this work? And if Google says yes, the answer is yes, and I put it in my book. So this was a bit more difficult when I had to go and I had to find really good sources and those kinds of things. But I would love to do this and continue doing this just for my own interest because I like this kind of thing.
As an example, Andy Weir, who did the Martian movie that was out in the book and everything, he had a source that I didn't have growing up. I didn't have the internet. Right? I didn't have the internet until I started working at NASA. He used that as his source and picked on a lot of different people information to help build his story. And anytime we can provide you guys with more opportunities to get exposed to things that you like to do or might like to do, I think we should.
Yeah, that's great. And NASA's program with students and just having the Space Center open is really educational and great and stuff.
So there's a high school aerospace scholar program that they do. There's also a college co-op that you can do, but some of that's a little bit more focused on very specific interest. But by the way, what I said earlier is still true. There's still just about anything you can think of as far as something that you like to do. There's somebody there doing it. You don't have to be an engineer.
I can't imagine us in like personal trainers and like, wow.
Well, human physiology in space is very important, and maintaining muscle mass and bone density, and eating the right things. We have dietitians that have to prepare food that needs to be up there 6 months at a time. It's freeze dried so that it will stay fresh somewhat. Some things you can't bring up, like bread.
Tortillas.
You know, your tortillas stay in your cabinet forever and they don't mold or anything. You're like, what's this thing made out of? Why is it not molded? The bread I opened up yesterday is already molded.
Oh, so bread with that, so they.
The bread's crumbly
Okay.
and it doesn't freeze right there. It's kind of the same thing as ice cream. That's a
But
total.
Dippin' Dots, everybody loves Dippin' Dots.
Well, Dippin' Dots are kind of just crumbled ice cream, aren't they?
Actually, we have a minus 80-degree freezer. We call it melty. Everything's an acronym in NASA. We'll send up fresh food in some of these cargo spacecraft and things like that, and the freezer, of course, we can send stuff up. You shouldn't just fly up anything, right? So they've sent Bluebell up there. It didn't last very long. And fresh fruit doesn't last very long, but everything else is pretty much freeze dried. You add hot water to it, and you're good to go.
I have one last question. And this is just a trivia, because a long time ago, I used to remember hearing that the space suits were like $1 million a copy, or they up to $2 million now.
Well, considering what I sign off on when we build new parts for the suits, 30 to 50 is probably a better number.
30 to 50 million?
Yeah, and this was long time ago. I was remembering they were saying they were like $1 million copy. Wow.
The suits have come a long way. We don't make them for the individual anymore. We have sizes, and it's a 3-day process to measure your body size, because everybody's fingers aren't the same way. This foot's bigger than that foot. You know, your legs are certainly. So we have a small, medium, and large. We actually don't make the small anymore. So we have medium, large, and extra large.
Don't you make the
tall
small?
for the suit. But there's a waist a brief, and then there's legs and then booties and the lower legs and upper arms and lower arms and that sort of stuff. And then there's what they call a hard upper torso. They call it the hood. And it's all about mobility, right? But you don't have to walk, and with the suit's life support backpack and everything, it weighs about 300 pounds. So you really can't walk with it here on Earth, but you can float with it in the pool and out in space. But they've added things over time: heaters, cooling garments. Because you can't really manage temperature because you could be out there in full sunlight, it's plus 200, or in total darkness, it's minus 200. And so you have to be able to preserve the life that's inside the suit. There's a drink bag that kind of fits right here in the suit, and a straw that comes up. And you can drink. There's probably half a liter of water in there. They used to have a snack, but they don't put the snack in there.
Yep. It's definitely changed.
Alright, in 1 minute, Ms. Kim asked a question. She wanted to know if the windows have to be made of a specific material to make sure they don't break. Yes, they have to be made of very strong material, plus a material that will, it has to, be dark enough to not hurt the eyes or cause unnecessary damage to the astronauts. So they'd probably be made of the same or similar material to the visors on an astronaut's helmet. They pull it down, it becomes incredibly reflective, and that's what they use when they're in the sun. Because the sun's very bright in space, we don't have the atmosphere to help get rid of, disperse the light. So it's very bright in space. So it's probably made of a similar material to that. I didn't do very much research into window materials, but I did try to do my best to take that into account when I was designing my base.
Because I thought the idea of putting lots of windows in there, as long as they're structurally safe and sound, is really good. Because you're right, stuck inside.
Yeah.
You're going to go a little bit crazy. So
Yeah.
these are good.
There are actually multiple things at the space station.
Yeah.
And it's fairly thick glass. It has other chemicals in it to make it hard, kind of like Gorilla glass, right? There's also a cover on it, so that when we're not using the window, not looking out of it, you have to close it to protect it from micrometeoroid debris up in space. Obviously, on the planet, it might be a little different, but and then we also have scratch panes so that we can still take really good pictures out of it. We put these, basically the same thing that's on your phone, your little Invisage Shield thing, right? So that we don't scratch the screen, the window, when you're trying to use it. The other thing that you need to know about is everybody's got a laser pointer these days. And other countries also use lasers for guidance, for tracking things, for sending projectiles places. And the space station gets irradiated a lot, so they have to wear actual special glasses when they're up there by the windows because the laser striking them, you can run away. That's why you're not supposed to aim your laser pointer at your eyes.
Yeah.
So you have to have them wear special glasses when they're next to windows, so they don't get their eyesight damaged. Because as it is, just being in space changes in fluid that affects the shape of your eyes, and they lose vision. Is kind of a permanent change in you didn't wear glasses before, you go afterwards. Some things you can gain back over time. Scott Kelly went up there for a year, almost a year. He's still recovering from his year up there in space.
So yeah, and on the moon, you're probably gonna have different situations than on Mars, because Mars has an atmosphere versus in space, because space has debris. So you have to take that into account. So I was just kind of going for a general thing that kind of went with everything Matt was saying, and what I thought what was gonna look good, because you have to have that kind of look. Don't want to be stuck to the side all the time. So what was your question?
I was listening so much, I almost lost my question. No, it's okay. So, in coming up with your presentation and during the mentorship, you had to do a lot of research. I was wondering, and kind of, I guess you could chime in as well, what has NASA already achieved in terms of research about what's happening on Mars, what's there, what's not there? what have we already learned about what's happening on Mars?
So we've been sending they're not drones, but we've been sending orbiters to Mars. We've been sending rovers to Mars for, a long time.
Okay.
So we've learned a lot of things. We've just recently sent a rover that's going to be taking measurements on things like seismic activity on Mars, the atmosphere, chemical compositions, all that kind of stuff. So we're learning a lot about it, and the goal of the base is to learn even more than what the rovers can tell us. So we're just currently getting a feel for Mars. We're trying to find good spots for landing, good spots for building, because to build the base, you have to bring it, you have to build it there. And so my base actually was designed with the same materials as the area around it, and that's because it was made of fine sand, stones, anything larger than, anything large was filtered out, sand mixed with the binding agent, and that was what was used to create that. And there are 3D, and if it had been real life, there would have been 3D printers there that would have built the whole thing. And it's the same idea on Mars. You're gonna have slightly different binding agent because it's made of different materials. So we're trying to figure that kind of stuff out at the moment. One thing in The Martian, the movie, that sandstorm at the very beginning, if you guys remember that, that was huge and it was like terrible. Mars doesn't have an atmosphere big enough to sustain a sandstorm like that. It's 0.5% the size, the density of Earth's atmosphere. It's tiny.
It's sticky.
It is sticky, yeah. All the stuff there, everything's gonna be like, you bring that stuff inside, you don't have a good airlock. That's why I had airlocks everywhere. Those iron doors on Minecraft, those were airlocks. I had them everywhere to keep contaminants from spreading. You come inside, you have to take a shower. You have to very likely, most of the stuff that's outside is going to stay outside. You're going to leave spacesuits outside. You're going to leave your anything that goes outside stays outside. Just because if you bring it inside, it's going to get everywhere, and it's bad for your health. It gets in your lungs, it gets in your eyes, it gets in your stomach, and it's not good for you. So we're figuring out how to protect against that kind of stuff and build the thing. We have to get there first, then we have to build it. So, any? All right.
Good job.
Thank you.